I don't know who these people are, by the way, but these little girls look really cute and they're identical. Actually, my wife watches this weird show called Tiny Twins. Anybody ever heard of that? Tiny Twins. There, let's see. Yeah, these. She's obsessed with watching this show. Let me put them in instead. They're pretty cute too. Um, anyway, so there's a reason why I'm doing this, obviously. So we're going to take a little bit of notes, and also we're going to do some Khan Academy. Okay. She likes drama shows. I asked her, why do you like drama shows, like reality? She's like, well, because I don't like drama in my life. So I just want to watch other people have drama. All right. So let's see what we have here. Let's call this notes number 16. And we're going to call it twins, multiplying twins. And I'm making that up, by the way. Number 16. It's called multiplying. They're not called twins, by the way, in math. That doesn't look right, huh? Multiplying. Probably doesn't need two Y's. A Y. Multiplying. That doesn't look right either. Oh, well. Twins. Okay. And I'll put quotes because they're not called twins. All right. So we're going to come up with a binomial. And multiplying does have a Y and an I. Okay. So we're going to multiply some twins. And let's make the first one identical twins. So here's one. Let's do x plus 5 times x plus 5. See, that's why I call them twins. There is no other math teacher that calls them twins. So it's just, to me, I always see things in a weird way, but kind of helps. Maybe it helps you. All right, so we're going to make a box. And this box is going to be a perfect square because they're twins. This length is the same as this length. They're exact same width and height. And this is one of the twins. And here's the other twin over here. Okay. All right. So let's get some participation in here. What do I put inside the area model? And by the way, I usually
x to the second.
Yeah, x to the second inside the first square, right? I usually like to make that little line bigger. And again, that's my thing. So inside, Marcia, we're going to put x squared, okay? And then here, what are we going to put in the other boxes?
5x, 25.
5x, 25, and what else?
And 5x.
5x.
Again.
Hey, look. So what I want you to see is that twins give you the same number here and here because they're twins. They're going to give you the same thing, right? So we're just going to add them up. We're going to double them up, okay? So what does this convert to? It converts to x squared, right? Plus 5, oops. 2 sets of 5, right? And then plus 25. And this is a special case. With time, you're going to be able to do this without doing that at all. Because you know they're going to be twins. They're going to give you 5x. This is going to give you 5x. This is going to give you 5x. You're going to add them up in your head, and that's going to give you 10x in the middle. And then 5 times 5 is 25. All right, let's do another set of twins. And let's see if you could do this without doing the box. Okay, x minus 3 squared. Are these twins? Is this the same thing?
Yes.
It is. So what is it? What's going to be in our imaginary box? Like here, I'm going to do the box, but without really doing the box, right? Without having to do the box. But if you can, if you want, what's going to go inside here?
It's going to be x to the second,
X squared.
and then negative 3x, negative 3x, and 9.
Good. And now remember, there's going to be two negative 3x's. So what do we got to do with those two negative 3x's?
Add them together.
Add them together. So it'd be negative 6x. And then inside of this one, it's going to be 9. Now, you don't have to skip the step. You can actually always do always do this. This always works. But I'm pretty lazy. I already know for sure the first one's going to be x squared. I know the last one's going to be 9, and then I know that the middle term, because they're twins, it's going to be these two multiplied, right? And then doubled.
Do we have to draw the box in our notes?
No. So what I'm trying to get you to understand is that you don't have to draw the box for twins, but you can, right? You can, right? I'm just saying you can actually move up like a level, right? You level up, right? You're like, oh, they're twins.
Yeah, I think I'll probably stick to drawing boxes when it comes to like problems like these, because I think it's just the methods that I'm most accustomed to. So.
And I definitely appreciate that, right? So I want to make sure that you guys know that the box works, right? So for twins, this is called a perfect square. Now all squares are perfect, but I don't know why they call it perfect. Do you guys agree that all squares are perfect? They're all the same size. Okay.
Yeah.
Now it's a perfect square because this length, x minus 3, equals x minus 3. So it's going to make a perfect area model. Like it's going to be a square. It's not going to be a rectangle, right? Even though we always draw them as a square, it actually is a square. Okay. All right, let's do one more, and you guys decide how you want to do it. Okay, these are still identical twins. Let's do one that has another number in front of it. Let's do 2x minus 3 twins. This means square, which means twins. So go ahead and try to do it with the area model or without the area model. So try to see whichever one works for you. Okay. Go ahead and multiply it through and see if you get your answer. Okay. Go ahead and try it out. I'm going to do it here, but don't look at my answer until you're done. Okay. Okay. Don't look at the screen anymore. Okay.
I have a quick question.
Yeah.
So when we're multiplying the 2x, would it become 4x squared or would it become 2x squared?
Exactly. Good question. So you're going to have 2 times 2, which would definitely be 4.
4. Okay, cool. I was wondering if we would multiply that.
Yeah, because you're multiplying 2x times another 2x. So you want to do the numbers separately, right? 2 times 2, and then do the variables separately.
Yeah.
Okay.
Okay.
All right, so if you finish the area model, or if you did it in your head, here is the answer you should get. Now, notice I did it without the area model, right? Now, I kind of do this separately in my head. If they're twins, I know there's going to be this squared, so it's going to be 4x squared. And then I know the last term is going to be negative 3 times negative 3. And I know the middle term, the middle one, is going to be these two multiplied and then doubled. So I just put negative 6 and then doubled it, it becomes negative 12. Okay. Like I said, and like Travis also said, you can use the area model all the time. Okay. All right, try one more. Okay. Let's see if I can mess with you guys. All right, go ahead and do that one. And I'll do it in my head. You do it in the area model, or you try to do it in your head and then get the answer. Okay. All right, kind of watching you guys. Let me see if you guys are having any questions. Like I said, I'm not trying to force you to do it in your head. I'm just trying to show you that it is possible. Okay, for twins, right? Identical twins. All right, I'm ready to put my answer. Okay. I had to slow down on the middle term. Okay. Did anybody get something different, or is there any questions on this one? Oh, I made a mistake. Now it's twins, right? I had forgot to put the twins. I think you guys assumed that I was there too, but that was a mistake. All right. Any questions so far on the identical twins? And the reason I call them identical twins is because they're two of the same thing, right, that are multiplying. All right. This time, we're going to try, let's call these fraternal twins. Okay. Fraternal. Let's see. Okay, fraternal twins. Sorry, I was getting a text from Mrs. Smidgen. All right, so here's a fraternal twins. They're kind of almost the same, but they're opposite. So they're not identical. And here's my example: x minus 7, x plus 7. Okay, so with fraternal twins, they're the same numbers, but one of the signs is opposite. Okay. Let's see. Let's go ahead and do the box and go ahead and see what happens. Okay. All right, let's do the box. Let me slide this up a little bit. Now, this is not going to be a perfect square because one of them is x minus 7 and that was x plus 7. So they're not going to be the same length, right? So x minus 7, x plus 7. So this is still x squared. This is negative 49. What happens, what do you notice about fraternal twins and these numbers? What do you guys notice about these two numbers in the corners?
One is positive, one is negative.
Exactly. And what is 5 minus 5? Or 7 minus 7? Or any number minus the same number?
0.
0. So they cancel each other out. They basically blow each other up, right? So with fraternal twins, there is no middle term. By the way, these are my favorite. Fraternal twins are my favorite because there is no middle term. So it's basically just going to be the first box right here and in the last box. By the way, if they're fraternal twins, do you think this sign right here will ever be positive? If one of them has to be negative and one of them has to be positive, will this sign ever be positive?
I have a question. Yeah, so why is it negative, actually?
Because it's negative 7, good question, times positive 7. Do you see that right here? Remember, they're opposites, right? Negative 7 times positive 7 is negative 49.
What if it's two different numbers?
Then they're not fraternal twins anymore. Good questions, right?
Oh, so they have to be the same still.
Yeah, and that's why I brought about my little pictures of twins, right? Make sense?
Yes.
Like for my little cute little girls, they're
Either way.
identical twins, right? They got to be the same. The tiny twins, this is shown, I don't know what, they're really funny. They're also identical. And these are twins right here, whoever these people are. But they're not identical, right? So they're opposites, right? This is a girl and this is a boy, right? Make sense? Good questions. So this only works for twins, whether they're identical or fraternal. Now, my favorite are fraternal twins because these two cancel each other, right? This one cancels what? That one. All right, let's try it with another one. Okay, Claudia, can you give me a fraternal twins?
X minus 5 and then X plus negative 5.
It'll be X plus 5, right?
Oh, X plus 5.
Yeah, there we go. Now they're fraternal twins, right? So go ahead and try it out. So you look at them, oh yeah, they're almost the same, right? So they're almost the same, but not. Boom. Done. But this only happens for fraternal twins. Now, they're not called fraternal twins from any math term at all. Just that's the way I see it, right? Like, oh, they're almost the same, but one sign is different, right? Okay. All right, let's try something else. All right, Amar, can you give me a set of fraternal twins?
Sorry, say that again.
Can you make up a set of fraternal twins?
Yeah, sure. So X plus 9 and then X minus 9.
There you go. All right. So at first you look at it and you're like, oh, these are fraternal twins. So what's going to be the answer? What do you guys think? Anybody? Nathan, what do you think it's going to be?
Negative 91 or negative 81.
Yep, negative 81. And don't forget the first part, the x times x.
X squared equals negative or minus negative.
Yep, exactly.
Is negative 81.
Yeah, x squared minus 81. Make sense? There we go. So you could definitely still do the area model, right? Area model. But I do want you to graduate from the area model.
So I have a question.
Yeah.
So if they're fraternal twins, do the X's always cancel out?
All right, let's find out. Look. 9x minus 9x, that cancels out, right?
Yeah, but I mean, is it always going to cancel out, or?
Let's pretend that I didn't know that, and let's try some other different one, right? Let's pretend like, let's make up one that it has a number in front of it. 2x minus 1. And what is the fraternal twin of this, of 2x minus 1?
2x plus 1.
2x plus 1. By the way, the fraternal twin has a fancy name. You don't have to know this, but it's called a conjugate. The conjugate is the other twin. Okay. All right. So let's.
Getting a telephone ringing in the background.
Yeah, I don't know whose. It's okay. All right. So here is my area model. Okay. 2x minus 1, 2x plus 1. All righty. Let's see. We got here 4x squared minus 2x, 2x. And look, these two definitely cancel each other out. Do you see that, Mar? They definitely what?
Yeah.
And this is always negative because one is negative and one's positive because they're fraternal twins, right? They got to be opposite signs. So this turns into 4x squared minus 1. All right, and I just have one last one for you. let's make the first term be the opposite, okay? How about negative x plus 5? Let's see, let me pick on Nathan. Nathan G. Nathan, what is the conjugate of negative x plus 5? What's the fraternal twin of negative x plus 5? What do you think? Give it a try. So what would be the twin of negative x plus 5?
So I can answer.
Yeah, go for it. What do you think it could be?
All right. So okay. So it's either x minus 5 or x plus 5.
All right, let's try that. It's either x minus 5 or x what?
X plus 5.
Plus 5. Okay. All right.
So I just didn't know whether to like make both of them opposite or just the x.
Right. See, look at the our previous examples. Only one of them is opposite, right?
Yeah.
So which one is already negative on the first? The x. So let's make that one opposite.
Okay.
So it would be what?
So it would be positive x plus 5.
Exactly. All right. And now let's find out what happens here. Okay. Let's do the area model. It's kind of a weird one, but it'll work. Watch. x5. All right. This is going to be negative x squared. This is going to be 5x. This is going to be negative 5x. This is going to be 25. So this still cancels that one, right? So the answer is negative x squared plus 25. Good job. So it would be this one right here. Okay. All right. The twin of one of the twins called a conjugate. Like I said, you don't have to know this, but when you get to pre-cal, then we'll use that. Okay. All right. So that is my twin lesson. All right, let's review real quick. Okay. Identical twins, they double up. These double up, right? 5x and 5x becomes 10x. Negative 3 and negative 3 double up, turn into negative 6. Fraternal twins, they cancel each other. And this is always negative. And like I said, you can always use the box, but have you ever ridden your bicycle? You can always use training wheels. Do you guys agree with that? Right? You can always use training wheels, or you can take them off, right? All right, so now let's see what Khan Academy is asking us to do. Let me go ahead and assign it. And it's going to be short today because it's just twins. They're either identical or they're fraternal twins. All right, let's go take a peek at Khan Academy. And good job, guys. I was checking your guys' grades. Yes. Oh, I think I signed up for the wrong class. Nope, I didn't. Lots of 100%. So great work.
Oh yeah, I also noticed that the missing assignments in the grade book weren't graded, even though you said you'd grade them yesterday.
Yeah, I got a little lazy, so I'll do it today for sure. Okay. All right, Travis, which one would you like to do? Would you like to do the fraternal twins first or the identical twins? Either. Okay. Let's do the fraternal twins because they're easier. All right, just watch this for a minute, and then I'll go ahead and do it, and I'll wait for you guys. Okay. All right. So the fraternal twins are going to be the ones that are like almost the same but opposite, right? Almost the same but opposite.
Yeah. I don't think I got anything.
Yeah. Okay. We'll wait for a minute for it to load up. I think like yesterday it took a minute. All right. So let's. I'll just review it here first and then give it a second for it to catch up. All right. All right. Difference of squares. All right. Just take a peek at my screen for a bit, and then we'll wait for for a minute. All right. So we have it's coming right now. Come on now. All right. Definitely fraternal twins, right? One's positive, one's negative. So this is going to be 4 minus x squared. And you could do the area model too, you know. I'll do one more. Fraternal.
Isn't it x squared minus 4?
It was 4 minus x squared.
Minus 4.
Yeah, so you could have also put negative x squared plus 4. So you could have switched them around, but take the negative with it, right? So this one's going to be 25 x squared. Now, since they're fraternal twins, the middle term is going to disappear. So I'm just going to multiply negative 1 and 1. Okay? And that's going to be... All right, let's take a peek and to see if you guys show the assignment now. Let me know if you don't. If you don't see...
I still don't.
All right, let me try it.
Why don't I go check right now?
All right, let me, I'll try something else. Like yesterday, I did something different. All right, practice, difference of squares. All right, let me assign it to that one. And that one.
Yep, I got.
You got them now?
Do assignments on Khan Academy, I think.
Okay, so I think I know what I got to do now.
Yeah, I think I do.
Yeah.
Pretty sure.
All right, so go ahead and try the one that's called multiplying difference of squares. And difference of squares, difference means minus. So one has to be a minus, one has to be a positive. This only works if they're twins or almost twins, right? So take a peek, everybody, and do that one first, and I'll do it again. And if you want to do the area model, go ahead and do it. It's okay. It's totally perfect. But I do want you to see how simple it is if you understand it, right? All right. First, I recognize that they're almost twins. So one's negative, one's positive. That's the first step. And I know the middle term is going to disappear. And this is always going to be negative because it's going to be 8 times negative 8. So basically, it's x times x and 8 times negative 8. So go ahead and try it out, everybody. And then let me know when you're ready to do the other one. Right? All right, see how simple it is. When you do the, let me know when you guys are done, even if it's a little chat. Just when you're starting the other one.
Can I draw the boxes on my notes page?
Yeah, that sounds good. Yep.
All right.
Yeah.
Cool.
Yeah, do that. Let's see. We have perfect squares, and the identical twins are called perfect squares. Okay. So go ahead and draw the box until you're ready to get out of that, right? I'm doing the perfect squares now in my head, and I kind of imagine the box in my head, by the way. And let me know if you guys are stuck with one or understand one. Yeah, I'll start that one again. And if you want to write in your notes, the identical twins is called perfect squares, and then the other one's called difference of two squares. I have a hard time remembering the names. I just know how to do them. That's all. That's what matters. Let's see here. I'm going to use the area model for this one just to show you. Okay. So you want to there we go. So I'll leave it right here. This is the perfect square. This is the screen that has that in case you need some help on that one. Like I said, you can do the area model or skip it and do it in your head because you know that on a set of perfect twins, these two are going to double up. This one and that one, they're going to double up, which means they're going to be times 2 or just double them. All right, and good job, Sophia. You got it. And if you're done, just go ahead and say bye or something. We're done for today. I'll put a thing so you can post your notes on this one. Let me do that right now before I forget. Code Academy. Okay, 1, 2, 3. Classwork. Number 16 notes. There we go. Okay. All right. Bye-bye. Bye, Nathan. Okay. So when you're done, that's all we have for today. Okay. When you got your two of them. And by the way, this is actually going to be really useful later on because we're gonna have to go backwards. We're gonna have to go from here to the twins. We're gonna make twins. You're gonna hear me saying that over and over. Let's make some twins. All right, Hayden got his 100. Good job.
Bye,
Hannah
Mr. Jimenez.
Bye. Good job. Okay. Travis got his. Colin, Devin, Nathan, Amar. Good job. Savannah. Nice. All right. Let's see who's left over here. Good. And just to give you guys a little secret, the twins, the identical twins, is vertex form. You guys see that? The identical twins is vertex form. So we're going to be able to take standard form, make twins out of it, and we'll have the vertex form, which is my favorite form because it gives us the vertex. So we're gonna be doing the area model in reverse. Okay, we're gonna start tomorrow. Okay, we're gonna go real slow because this is like the hardest thing that I can think of in this, and I'm too. Bye, Hannah. Good job.